Hi, welcome back to Father-Offspring Interviews. We have reached episode 40. With that comes an update, which is that this podcast is now available on Spotify and Apple Podcasts, so you can listen on the go. Those are linked in both the YouTube and Instagram bios, as well as in the YouTube video description. All right, we're going to get right into it. So to start, Lena from Greece asks, for someone who doesn't have a clue, what is the deal with sociobiology, and is there some controversy attached to it?
Massive controversy that's somewhat dying down. Sociobiology, the very word was considered inflammatory. It constituted one of the great sort of intellectual debates, controversies of the last quarter of the last century. And in principle, it should not have been particularly problematic. It's a very simple idea, which is evolution makes sense. Evolution makes sense. You are interested in the evolution of the heart, for example. So you get something like a giraffe and you see that its head is whatever number of feet up above the ground, and you do all sorts of fancy calculations and say the only way a heart could pump blood straight up to a head is if the walls are this thick and it pumps with this contractive forces, and then people go and measure it. And that's exactly what it is. Isn't nature wonderful? It's got to be. It's got to be. If you're going to have your head way above your heart like that, you've got to have a heart with a certain number of properties. And what do you know? It evolved that way. The hearts of giraffe found an optimal solution to this evolutionary challenge. And what sociobiology is about is the notion that the evolution of behavior, the evolution of social behavior, is subject to this as well, that we have evolved under various selective forces and come up with behavioral, quote, solutions to some of these problems, which is where things get complicated. So what would a solution look like for a behavioral problem? Tic-tac-toe. Tic-tac-toe, there's a way of playing tic-tac-toe, which I no longer remember, which means that you cannot ever lose. Every single time you play, you will either win or it will be a draw. That is the solution to tic-tac-toe. And the whole sociobiological approach was that there's a solution to a lot of the challenges of social behavior. So what that was originally about was a whole bunch of completely wrong ideas about the evolution of behavior. Why do organisms behave the way they do? Two different ideas that led people into the wilderness for years. The first one is that organisms behave for the good of the species, something that was termed group selection. And organisms don't behave for the good of the species. They behave for their own self-interests. The second erroneous notion was self-interest took the form of survival. Survival of the fittest. If you survive, that's your evolutionary goal. And that is, in fact, not what it is. It's leaving copies of your genes. Jargon, your reproductive success. If you live to be 5,000 years old and you never pass on your genes, you are evolutionarily invisible. Behavior evolved for individuals driven to pass on as many copies of their genes as possible. Okay, so pulling that apart, what people sort of began to frame things as is three building blocks to sociobiological thinking. First one is what would be termed individual selection. Behaving for the benefit of your own genes, your behavior is directly meant to optimize your reproductive success. And the notion there is all of behavior is just a means of getting your genes into the next generation. Wonderful quote about that. Sometimes a chicken is just an egg's way of making another egg. So individuals, and this is the drive for reproduction, whether you are salmon spawning or elk or moose or however they go about it. So individual selection, driven by a concept supplied by Richard Dawkins, the notion of the selfish gene. Second building block, which is some of the time you can leave as many copies of your genes in the future generations as possible by reproducing yourself, but some of the time it could be by helping your relatives reproduce. because they share genes with you. A full sibling shares half your genes with you, and you then are given this like Darwinian logic of if the same behavior allows you to pass on one copy of your genes or allows a full sibling to pass on two copies, by the rules of how the math works, it's exactly the equivalent. And thus, the second building block is the idea that a lot of maximizing a reproductive success is built around cooperating with relatives, term called kin selection. And the notion is the more related you are to an individual, the more genes you share in common with them, the more of a shared investment you have in them passing on copies of their genes. Wonderful version of this idea, which was this geneticist Haldane back in the last century, it was wonderful, once said, "I will gladly lay down my life for 2 brothers or 8 cousins." Because that's what the math works out to be. So animals behave to maximize their own reproductive success, to optimize the reproductive success of their close relatives as a function of degree of relatedness. And then the third leg of the whole thing is what came to be called reciprocal altruism. Sometimes it makes sense to cooperate with another organism, even if they're not a relative of yours, not an example of kin selection, to cooperate with them under very, very special circumstances, mainly if you trust that they're going to reciprocate. And if you do trust them, you could form stable reciprocal relationships of cooperating with each other. And this opened up a whole world of game theory strategies of when do you cooperate? When do you stab someone in the back? And game theorists have been working on that forever. And okay, so we've got these 3 big pieces: individual selection, pass on direct copies of your genes; kin selection, help your relatives do that. And sometimes this could be fostered by cooperating reciprocally with other individuals. What would this look like? Individual selection, male baboons fighting with other male baboons to pass on copies of their genes. The leading cause of death among the baboons that I studied were male baboons, either direct or from the indirect consequences of injuries. Individual selection, selfish gene fighting to do that. What would kin selection look like in another species? You look at baboons and you look at who they're grooming. Females, who they're grooming, and they're grooming as a function of relatedness. So a mom and her daughter are doing a whole lot more grooming than a mom and her niece, or mom and a stranger. And you can see sort of gradations of relatedness predicting how much grooming going on there. So kin selection in that regard. Reciprocal altruism, you're a male baboon and you got another male, and the two of you work out a cooperative coalition to try to take down number one on the hierarchy, and you have to spend a lot of time setting up this coalition with this other guy, a whole bunch of ritualized things built around basically saying, I'm not pissed off at you. You're not pissed off at me. We're not pissed off. We're really pissed off at him. So why don't we join up? And you see cooperative coalitions like this can be great. And you see the game theory cooperate or cheat sneaking in with sometimes it makes sense to cooperate with your partner. And sometimes it makes sense in the heat of battle to bite him in the ass instead, to switch sides. And okay, so we see what another species would look like with individual selection, kin selection, reciprocal altruism. So then we get to humans. And the first pass at it is, it's totally logical. It's exactly the same as in every other species. And what would this look like in humans? Individual selection. Humans behave to pass on copies of their genes. Great example of this. Current estimates, I believe there are 16 million people on Earth who are direct descendants of Genghis Khan, the most reproductively successful human of all times. And, low-rent versions of it. Elon Musk has 12 kids by 3 women, and the horror of that is made even greater by the names of the kids. And so we got humans, and very often human males, we'll get to that, trying to maximize their individual selection. Good. Kin selection. Kin selection have invented something that like makes baboons with like mothers and daughters grooming each other preferentially shrivel up in envy. We write wills. We leave money to the next generation. We leave resources, and we typically leave it as a function of degree of relatedness. Whoa, perfect kin selection. And then we see a great example of like reciprocal altruism. Every economic system on earth, including the strategic decisions, whether to cooperate or cheat and all of that, starting with the simplest bartering ever. That was just, so humans fit. It's totally great. We're just another species out there, which was the stance of sort of the first generation of sociobiologists. And where they got in trouble was in a couple of different ways. The sociobiologists, and soon their like offspring, a discipline that came to be called evolutionary psychology, sociobiology, social behavior evolves as a function of the forces of natural selection. Evolutionary psychology, our psyches have evolved that way as well, just an extension of it. And where did the wild controversy come in? First off, it was because a lot of the sociobiological predictions didn't work very well when it came to humans. Ooh, individual selection, human males maximizing the number of copies of genes they leave in the next generation, human females wanting to have babies who are healthy. And then you get people who choose to be celibate. Then you get entire like cults like the Shakers who went extinct because none of them reproduced cultural inventions that override any of this, individual selfish gene stuff. Kin selection, totally obvious how that works in humans. But then you see blended families where you get two people from incredibly different gene pools who have children that they've adopted from the other side of the planet and who they would lay their life down for gladly and who they're going to leave every resource to when it comes to filling out a will. And they don't share any copies of genes with human constructs of things like adoption and heterogeneity of mating and things like that due in the notion that we're just like every other baboon and every fern and every, tadpole in terms of kin selection. Finally, reciprocal altruism, as the name implies, the key thing that drives altruistic behavior is the expectation of reciprocity. Or indirectly so, if you were observed to be being a good guy and helping out someone, that will increase their trust in you, secondary reciprocity, reputational stuff like that. Okay, so that explains everything. But what about this? You're in some foreign country, you're going to the airport, you're just about to fly out from there, you are never going to that place again, every person around you you will never see again, and as you enter the terminal, you pause for a second and hold the door open for the person behind you. Nothing in sociobiological thinking could ever explain that. Not only will you never see that person again, you're never going to see any of the people who are observing you being Mother Teresa like that. And when you look at humans, a lot of the formal models break down. And in fact, most of them break down because we're idiosyncratic thanks to culture. We're idiosyncratic thanks to personality, thanks to quirks of everything in there. So the really nice, clean predictions of humans, just another species, extend the same rules, didn't extend very well. Okay, so that's great. That's sort of intellectually interesting. That's not the stuff of controversy. Where did the controversy come in? With a second problem. And this was back to this first generation of sociobiologists. This exploded in the 1970s, predominantly in Cambridge. And I had the great fortune of like being at college while all this stuff was blowing up around. And the leading people, E.O. Wilson, Edward O. Wilson, Stephen Jay Gould, Irvin DeVore, Robert Trivers, Richard Dawkins, Noam Chomsky, a little bit peripheral to that, all of them got involved in this. And there were the sociobiologists and there were the anti-sociobiologists. What's there to argue about here because of what is termed the naturalistic fallacy? the whole notion that if something evolved, it evolved for a good reason. And somewhere in there, there's a transition from this is how it is to this is how it should be. Ooh, we humans have evolved to be a species in which we tend to form hierarchical societies with high levels of male aggression and male domination of female. Whoa, that's how we evolved. That's how we should be because it's only natural. And just the firestorms of controversy were over the notion of some of the original sociobiologists saying, yes, indeed, this is as it should be. And others saying, no, we're saying just because we're describing, here's the cellular mechanisms of cancer, that doesn't mean we're saying cancer is a good thing. Here we're saying the same thing, yet people are misunderstanding it, a version of social Darwinism, that the lessons of evolution have a moral worth to them, which they sure don't. And the anti-sociobiologists were predominantly very left-leaning, and the notion was sociobiological thinking generated system justification and male dominance and dominance of some groups over others and the inevitability of war, and it's just how we evolved. And here's the formal sociobiological models explaining why this was the optimal thing to have evolved, why this was the optimal thing to this evolutionary challenge, this solution, and thus there's a confusion between what is and what should be. And sociobiology got hugely tainted with the notion of it being right-wing, conservative, reactionary, justifying the status quo, system justification, and storms over that. Over the decades, things have calmed down a lot, mainly because most of the members of the first generation are no longer with us. Edward O. Wilson, E.O. Wilson, who was really the prime architect of that, my freshman year of college, 3 out of my 5 classes had his writings as like the assigned text. Passed away a couple of years ago in his 90s. Things have calmed down. Everybody has got a little bit more housebroken and learned some manners. And the notion at this point is, yeah, just like every other species out there, our behavior, along with our anatomy, our physiology, has been subject to evolutionary forces, and that's been an influence, but it is not above everything else. And when you look closely, what do you know? We provide endless exceptions to the rule, sufficiently so that you can question how reliable the rule is. But that's been the controversy with it. It is now mostly a textbook controversy. Historians of science literally beginning to write about, to quote the title of one of the books, the sociobiology wars.
And this all relates back a little bit to our conversation about spandrels from a few episodes back. So be sure to go check that one out. Okay, so semi-relatedly, Alex from Wisconsin says, some people claim that men are biologically programmed to be non-monogamous, while women are not. We see this sometimes in other species. Do you have thoughts on this topic?
Yeah, this could not have been a better question to come in to show exactly what some of these sociobiological conflicts were about. Basic fact of virtually every mammal out there, of virtually all sorts of social species out there, which is how expensive is it for you to pass on copies of your genes? If you're a male, pretty much the expense involves making some sperm and scattering it around. If you're female, it's pregnancy, which is metabolically hugely costly, often life-threatening, and then you're raising the kid and lactation and all of that. It is more costly on the average for females to reproduce than males. And from that comes a logical next step, which is, as a result, females should be more selective as to who they mate with than males are. Males are less discriminating. And from that, you get a whole world saying there's a natural tendency for males, including human males, to be more polygamous than females are, to be less stable in relationships, to be more likely to cheat, all of that because the costs are far, far lower. Okay, let's unpack that a bit because this is exactly where we've got the sociobiological, look, it's evolved that human males stronger tendency to sort of reproduce outside the pair bond than the females do, and it's only natural. It's only natural. This is how we evolved. Let's unpack that a bit. Big surprise, enormous amounts of variability across different sorts of species as to mating systems, what they look like, all of that. And very broadly, you could break the interesting social mammals and birds and stuff into two different extreme flavors. First one, what would be called a tournament species. What's its characteristic? A small subset of the males dominate all of the mating. Okay, from that come all sorts of logical things. If it's only a small subset that are going to wind up winning the lottery, you see very high levels of male-male aggression because they are fighting for this sort of thing. So lots of aggression. What you then see is what are males selected for physically? Fighting ability. And you see this is where you observe high levels of what are termed sexual dimorphisms. The body differs based on the sex. The males are a lot bigger than females. The males have lots of muscle, or they have antlers, or they've got extra long, sharp canines, or they've got absurd coloration to attract females and things. So this whole world of sexual dimorphism, which extends into things like the metabolic costs of being a male are much greater than being a female. The life expectancies of males in all of these tournament species is a lot shorter than in females, a whole bunch of dimorphic features that come out of there. So it makes perfect sense. Only a subset of males ever get to reproduce, so they're fighting like crazy, and they've been selected for good fighting skills and for the anatomy and physiology of good fighting skills. What else do you expect to see with this? So your ideal male baboon, which is a tournament species, who in an Elon Musk fashion comes out the other end and has children scattered all over the savannah. Do you see a lot of male parenting in tournament species? Not in the slightest, virtually none. Virtually all of the child rearing is done by the females. So this brings up the question, what is each sex looking for in the other? If you were a female, what you're looking for in a male is you get nothing from this guy but sperm, so just look for markers that he's got good sperm. Is he muscular? Is he healthy? Is he looking for markers of passing on good genes? Because whether you think the guy is idiotic or not, if he's the one who's coming out at the top of the hierarchy, you probably want your kids to have those traits also. A self-fulfilling sort of mechanism for it. So females are looking for markers of good genes and health in the males. What are males looking for? Not a damn thing. Males are completely unselective. So these are tournament species, and you also see a class of genes, genetic diseases called imprinted diseases that are much more common in tournament species. So what are tournaments? Baboons are tournament species. Elephant seals, 5% of the males do 95% of the matings. Peacocks, where the males have all that peacockery and are much larger, and classic tournament species. At the other extreme, we got a very different flavor, which are what would be termed pair bonding species, monogamous species, where a pair mates and stays together for life. What do you see out of that? Well, you see as much parental care coming from the male as the female. In some species, in fact, after birth, the male is expending more calories, raising the kids that the female does. So if you're in that species and you're male, you have a rule that you mate with somebody and they give birth, you take care of the kids. So, do you go about trying to mate with everybody on Earth? No, males are much more selective because you break it, you fix it, or whatever the equivalent there is. You see far more male selectivity. You see far less variance in reproductive success among males. Everyone has a pair bond and they got 1, 2, 3 kids or so. It's not like 95% of them have 0 and the rest of. So there's very low degrees of variability in male reproductive success. There's higher degrees of male pickiness. You don't see high levels of male aggression because you are not fighting for the chance of mating with thousands of females, low levels of aggression. And going hand in hand with that, exactly as you would guess, low levels of sexual dimorphism. You look at highly pair bonding monogamous species, and you can't tell which is the male and which is the female. Same body size, because they're being selected both for being like good mothers, and males have this disadvantage that they're not actually female, but they're doing the best they can. You see a species where you cannot tell which one is the female and which is the male. You are looking at a pair bonding species. So that goes along with that. So we begin to get the mate choice kind of stuff. So you're a female. What are you looking for in a mate, in a pair bonded species? You're looking for a male who's going to be a competent father. What does he do? He has to go through rituals showing he's good at it. He's a bird, and he gets a worm and brings it to you as a gift. Look at what I'm capable of doing. And there's about 600 species of birds out there that are pair bonders, monogamous for life. And this is exactly the mating rituals that you sort of see. What do males want out of a mate? They don't just want anyone who's, they're looking for maternal competence and health. And so far more similar selection criteria. And in some of the most extreme pair bonding species where males are doing a whole lot more of the parenting, it's the females who have elevated aggression, fighting it out to get to like mate with Alan Alda or Mr. Rogers or something, where the competition goes in that direction. Well, you see their life expectancy is about the same, metabolism is about the same, and you don't see those imprinted genes. Great. So these are the two extremes. Monogamous pair bonded species, swans, those wonderful swans on the Valentine Day card, all sorts of South American monkeys are pair bonding, and you see something interesting with them. You're a female marmoset monkey, and it's guaranteed if you get pregnant, the male is going to stick around and do the bulk of the rearing. What can you afford to do out of your selfish gene interest in maximizing your own reproductive success? Have twins. Have twins because there's two parents taking place, and all of the South American pair bonding primates twin all the time. So you see examples of that. So we got our two extremes, sufficiently so you go into a rainforest and you spot some primate that's never been seen before on Earth, and like you see one is a lot bigger than the other one, and the big one you're managing to spot has a penis, and the little one is nursing somebody, and you know this is a tournament species. Or if it's two of them up there and you kind of see who they mate, but you can't really remember which one was who because they look exactly the same, you don't need to know anything else than that to know that you're looking at a monogamous pair bonding species. So what about humans? What about humans? And what you see is, by every measure, difference in body size, difference in lifespan, difference between the sexes in your average length of canines, by every measure of levels of aggression, by every level of mate pickiness that goes in over and over and over, what you see with humans is, wait for it, we're not a classic tournament species. We're not a classic pair bonding species. We're about halfway in between. Even to things like dimorphism in lung capacity, we're not as dimorphic when it comes to lung capacity as gorilla males and females are, but much more so than South American marmosets. So we're right in the middle. What does that mean? We're a species that's not classically either. We're right in the middle, and we're a species with lots of individual variability, meaning on a metaphorical level, some individuals are much more like pair bonding South American marmosets, and some individuals are much more like savanna baboons. Tremendous individual differences there in terms of individual behavior and such, and we know a little bit of the neurobiology, say, having to do with things like the responsiveness of your brain to hormones like oxytocin and vasopressin, how stable of relationships you form. You look at the level of cultural anthropology and you see exactly where all the confusion is, which is historically, most cultures on Earth have allowed polygamy. Despite that, most men in such cultures have been monogamous. Despite that, men in such circumstances are more likely than women to cheat on it. Moreover, in such circumstances, culture after culture has come up with all sorts of ritualistic ways of proclaiming monogamy to be a wonderful. So we're totally confused. And this is known to every poet or divorce attorney that humans are confused. We're about halfway in between in terms of all of those traits. So there is nothing inevitable about human social behavior from the standpoint of evolution.
And this appears to be the episode of callbacks, because a lot of this is a callback to a recent conversation we had about sexual selection and how the ratio of sexes is maintained. So make sure to look back at that. Finally, Dustin from Rhode Island says, "You've said that looking at genes outside of their environmental context leaves out vital info and overstates the importance of genetics alone. If genetic information only tells us a small part of the story, what, if anything, is the value of at-home DNA testing or personal genome sequencing? Outside of simple genetic diseases, e.g. sickle cell anemia, what can DNA tests actually tell us about our health and personality?"
Great. So we start off honing in the simple stuff where we're looking at a particular variant of a gene, a mutation in a gene and such guarantees a particular trait. And as framed here, guarantees a particular disease. You got the mutation, you're going to get the disease. And in those realms, it is very useful, obviously, to find out if you are carrying the gene. You've got two parents, one of them had a disease, you got a 50% chance of getting it, and sickle cell anemia, Huntington's disease, endless ones in that. So that seems very straightforward as to why you would want to get an answer to that. Naturally, that comes with all sorts of interesting bioethics. One of the first of these genetic markers for a fatal, we can't do a damn thing, horrible diseases with 100% predictability if you had the genetic marker was Huntington's disease. And that was often a test being done on a 20-year-old who just finished an appalling decade of watching their parents slowly wither away to that disease. And this immediately generated this enormous bioethics issue of, should people be able to find out? Should someone be able to know that's me in 20 years? If you do that, are people just going to commit suicide? Should people have that knowledge since we can't do anything about it? And should people have that knowledge over ridiculous stuff? Ooh, you have a mutation, and thus it is guaranteed by the time you are 75, you are going to have a ghastly amount of nasal hairs. Oh my God, my life is ruined. What do you do with stuff like that? So those are the versions that get complicated, even with the easy issue of you got the mutation, 100% certainty. What is being referred to here is the vast percentage of genes where the issue isn't a guarantee. It's not 100, it's probabilities, it's vulnerabilities, it's propensities, it's potentials, things of that sort. Why find out if you're not finding out about 100%? You're just finding out, ooh, I've got a 36.5% of having, ingrown toenails. What is it about? And this is hearkening back to the questioner saying something that should be emphasized, which I do endlessly, which is most genes don't control anything. They don't determine anything. Most genes are not the holy grail, the code of codes running every cell in your body. Saying that most genes tell you what to do is like saying most recipes in a cookbook tell you when to bake the cake. They're just the instructions. They're just the recipes. And what is it that's regulating when you activate the genes or not? Environment. environment, the main lesson that comes out of understanding how most genes work is it's silly to ask what a gene does. You can only ask what it does in a particular environment. So why bother doing genetic testing? For exactly that reason. Because you find out what sort of environments you are more or less vulnerable to. If you find out that you have some lung cancer gene propensities, and what do you do with that? You really should be in a certain type of environment, one that does not involve you doing something as idiotic as smoking. If you have a genetic propensity towards melanomas, cover yourself up when you go to the beach. If you have a genetic propensity towards one type of diabetes, exercise, don't get overweight, and what you get out of all those tests is wonderful information because it's telling you nothing about the inevitability of your genetics. It's giving you a prescription as to what the healthiest environments are going to be for you. So it's enormously useful.
And that is it for episode 40. Be sure to find us on Spotify and Apple Podcasts. And as always, keep submitting your questions at the forum found in the Instagram story highlight and bio or the YouTube video description. I'm Offspring Sapolsky, and thanks for your continued support of Science and the Beard.